You know, from bridges to wind turbines, our entire world is literally held together by something as simple as a bolt. It's an absolute marvel of engineering. But what happens when it fails? When that one simple bolt comes loose, the consequences can be, well, catastrophic. So today, we're going to pull back the curtain on the hidden risks lurking in every single bolt and explore the smart technology that's turning that dangerous uncertainty into cold, hard, data-driven precision.
All right, so let's start with the problem itself. It's a situation most engineers and technicians know all too well, even if the real root cause hasn't always been super obvious.
I mean, have you ever seen this? It's a frustrating, and let's be honest, a kind of terrifying experience, right? You find a bolt that's loose, maybe even missing, but the one right next to it is perfectly tight. You're just left standing there wondering, why? Why this one? It's a super common scenario, but it really points to a much deeper, more fundamental issue.
See, a loose bolt isn't just some minor inconvenience. It's a critical failure point waiting to happen. It leads to more maintenance, which costs time and money. It causes unplanned operational downtime, which can cost a fortune. And most importantly, it creates huge safety risks. We're talking about potential catastrophic failures that can affect lives and cost millions. This is serious stuff.
So why does this keep happening? I mean, we use torque wrenches, we follow the specifications. Shouldn't every single bolt be perfectly tight? Well, it turns out the answer is in this fundamental misunderstanding of what we're actually trying to do when we tighten a bolt.
And this right here, this is the key. Our goal isn't actually to apply a specific amount of torque. The real goal, the thing that actually matters, is to achieve the right amount of preload. That's the invisible clamping force that's holding the whole joint together. Torque is just the tool we use to try to get there, and as we're about to see, it's a pretty deceptive guide.
Okay, and here is the real kicker. On one side, you've got the torque. That's the turning force you put in with a wrench. But a huge chunk of that effort, often most of it, is just gone. It's immediately lost to friction. And that means only a tiny fraction of all your work actually becomes the clamping force, the preload, that's actually doing the job.
And this is what leads to the core problem. Because friction is so incredibly variable, it changes with lubrication, temperature, even the finish on a bolt. It becomes painfully clear why there's just no such thing as a standard torque. You can apply the exact same torque to two bolts that look identical, and you can get wildly different clamping forces.
So if the old way is so unreliable, how do we fix this fundamental problem of friction and uncertainty? Well, this is where a huge technological leap completely changes the game. It gives us a level of precision that honestly just wasn't possible before.
The solution is this one-two punch. You combine smart, data-enabled wrenches with intelligent workflow software. Platforms like BoltExpert can figure out the exact procedure you need, and then tools like ExcelWraps push that procedure right to the wrench on the factory floor. It creates this seamless, data-driven process. It's a total leap from an old-school analog problem to a modern digital solution.
But what kind of a difference does this tech really make? Well, the data shows this really clear ladder of precision. And the jump from one rung to the next, it's a total shift from guesswork to near certainty.
Okay, just look at the difference here. With the old-school peak torque method, you've got this massive, dangerous spread. The weakest bolt might have less than half the clamping force of the strongest. That's a huge problem. But watch what happens when you use a smart wrench. Moving up to angle mode closes that gap dramatically, to nearly 74% consistency. And with the most advanced method, yield mode, we're getting over 85% consistency across the board. That is what climbing the ladder of precision looks like.
But these tools do so much more than just tighten bolts accurately. Their real power, the true game changer, is in the data they capture. They create a complete digital record of every single thing that happens on a critical joint.
So this digital workflow creates this powerful, unbroken chain of data. First, the exact procedure is sent to the wrench, which makes it impossible for the operator to mess up and use the wrong one. Then, as the bolt is tightened, every single data point is captured in real time. Finally, that complete record is stored and digitally signed. It's a perfect closed loop of quality control.
And for total, absolute accountability, the system can operate in what's called audit mode. In this mode, the wrench isn't just tightening, it's recording a permanent digital fingerprint of the work, the torque, the angle, the yield values, all time-stamped. This creates an unchangeable history for every single fastener, giving you complete, undeniable traceability.
So what does this digital record really give you in the end? Well, it's a total transformation of the entire process. Suddenly, you've got bulletproof documentation for regulatory compliance. Quality control becomes practically effortless, and you have this rich source of data for constantly improving your process. It creates accountability and dramatically mitigates the risk of failure.
So, when you put all of this together, what you get is a genuine paradigm shift. We're moving away from a process that was defined by hidden variables and risk, and we're stepping into a new model built entirely on data, transparency, and rock-solid reliability.
By bringing these digital tools into the mix, the entire workflow just becomes more transparent, more accountable, and way more optimized. And this is about more than just tightening a bolt correctly. It's about building a system that fundamentally reduces the chance for error and ensures safety and quality from the ground up.
And that really just leaves us with one final question to think about. In a world that is held together by bolts, where failure is simply not an option, how certain are you about the integrity of your most critical joints? With the technology we have today, the answer can finally be 100%.